So the learning objectives for today are understand the NEC code making process and its impact on facility operations, learn the difference between electrical systems under Articles 700, 701, 702, and 708, and capture key 2026 code changes that affect power switching, service, and equipment. Now, a little bit about our presenter. Robert DeBrody, the Director of Program Execution, Product Manager at ASCO Power Technologies. Robert's primary duties include understanding and developing opportunities to meet the demands of the latest customer applications and to ensure the ASCO transfer switch product line remains at the forefront of engineering and design. Robert has an associate's degree in architectural design, a bachelor's degree in electrical engineering, and a master's in engineering management. Robert is also a professional engineer and has several patents. He also has served on an NFPA committee. So with that, I will turn it over to you, Robert.
Thank you, Lori. All right, we got a lot to go over today, so let me jump right in here. So today we're going to talk about the NFPA 70, which everybody knows or should know. It's more formally known as the National Electrical Code. And, you know, I used to think in the old days that, oh, this is just makes my job more difficult. Well, it really doesn't. It's really there to safeguard persons and properties from electrical hazard. And there's no excuse for not implementing what's in there. And it's for a good reason. Now, NFPA codes are updated either on a 3-year cycle or a 5-year cycle. This one has so much content in it, and it's so important that it's on the 3-year cycle. And in the creation of this 2026 version of the code, there were close to 6,000 public comments received by NFPA. So they have 18 code making panels that make up this specific code. And they took those almost 6,000 comments, they broke them up between the 18 code making panels, and they worked on them. They debated whether they should be implemented, whether they should be accepted in whole or in part, or changed some of the wording that's in the code. And after long debates and discussions and word proofing, on September 9th, they released the 2026 version of the NEC. So that's now available for adoption by any state or municipality. So now that the 2026 version is out, let's look beyond that to the 2029 version. In the 2029 version of the code, they're really looking to revamp the structure of the NEC to try to make it easier for people to learn, to find applicable portions of the document. So they're changing some sections. You can see it on the lower left here of how they're expanding some sections, changing the naming on some suggestions, combining things a little bit differently than has been done previously. So it's been a long time since they've ever done something like this. So there's some big changes coming in the 2029 version. And I'm saying we need to think about that because we only have less than 6 months before the public input closing date occurs. So not only do you need to get the new version of the code to 2026, but you need to submit any comments that you have, any changes, anything you don't like with wording before April 9th of next year. So then what happens after you submit your comments, they'll take them and for example, on this last go around, they had almost 4,000 comments received just in that first public input phase. They'll take a year and a couple months, I think it is here, to look those over and debate them and decide what they want to implement. And then they'll come out with the first draft report. And then you only have a month and a half to comment on that first draft report. And then that closes. And then, what is that? A number of months later, they'll come out with the second draft report. And once that second draft report is out, you can submit comments, but it's pretty much a done deal at that point. So it's going to be issued pretty much the same way that second draft shows it. So that just kind of gives you an overview of the timelines related to how a code is created and the timeframes you have to comment. So if you want to comment on the or put some inputs in for the 2029 version, you got to start now. start thinking about that. So this is the latest update that NFPA provides on the NEC adoption. Here it is by states. And as you can see, the light yellow is, they're on the 2023 version of the code. The purple is on the 2020 version of the NEC. The green on the 2008 version of the NEC. They'll never catch up, Indiana and Kansas. And the dark yellow is interesting too, because they don't adopt the code on a statewide basis. They usually do it by county or municipality, on whether they're adopting different versions of the code. So you may look at this and say, well, my state's on the 2017 version or the 2020 version. That's the most popular one that's out there now. There's 20 states on the 2020 version. Why do I care what's in the 2026 version? Well, because what's in that code and what they put in there is really probably good engineering practice. It's something that you should be considering doing. If it's not going to increase the cost of your project, as an owner, as a design engineering firm, you really probably want to try to implement as many of those suggested changes as possible. Even though it's not a requirement, it's probably a damn good idea. So there's so many changes, and even related to the sections I'm going to talk about, those are shown in green here. So I'm going to go over these. This is the foundation of the presentation today, but there's a couple other things I'm showing in gray here on the screen that I hope I have time to get to before we end up our meeting today. So we'll jump right in here. So I'm going to talk about the 4 electrical systems that are identified in the NEC. And these are where they talk about backup power and power transfer. And that's the focus of the discussion today. So in Article 700, that's emergency systems, 701, legally required standby systems, 702, optional standby systems, and 708, critical operations power systems. So this table just kind of gives you a quick overview of how the similarities and the differences between those different electrical systems. So if we look at the third column over, it says permanent for the type. That means that there's a requirement that there's a permanent backup generator on site or a power source on site. And that's required for the emergency systems and legally required. For optional, yeah, it can be either temporary or permanent. It really doesn't matter. In critical operations, they allow it to be temporary, but in most cases, you'll find that it really is a permanent backup power source there on site. Temporary would be if the time frame when you had to switch from the dead source to the backup power is long enough for you to get a temporary source in there and connect it up. So the code in all cases talks to the installation and operation to each one of these electrical systems. You see in the servicing, they don't address servicing for optional standby systems because really it's up to the owner to service his equipment appropriately based upon manufacturer's recommendations. On monitoring and control, the only place they talk about that in the code is in regards to the critical operations power systems. So what I'm going to do in the following slides is just to quickly touch on each one of these 4. We can go into a little bit deeper depth on what they're here for and what they do. So the first one up is emergency systems, Article 700. And this states that when the normal power fails, they want you to automatically supply illumination and or power via a permanent source that we already talked about within 10 seconds. And these are electrical systems that are essential for safety to human life. And when you think about emergency systems, what do you think? You think hospitals. Yeah, that is true. It's hospitals are included in here. But if you look at the photograph on the lower right here, you see a football stadium at night it's crowded full of people. So you can imagine what would happen if the lights went out, if power went out. Would this risk the safety to human life? Yeah, I think it would. So any place where there's a large congregation of people, these could be casinos, hotels, theaters, sports arenas, they are also considered emergency systems. And what you got to power up in that case is really the exit lighting, fire alarms, elevators, the fire pumps, communication systems. So let's go on to the next one. The next one is Article 701, legally required standby systems. And these are power systems where interruption of power could create hazards or hamper firefighting or rescue operations. And here, instead of requiring you to switch to the backup power source within 10 seconds, these aren't quite as critical as the emergency system. So they give you 60 seconds to transfer over to that backup power source. And here's just an example of some of the things that are addressed here. It's the sewage disposal, ventilation, smoke removal systems, communication systems. The next one up is 702. These are optional standby systems. And these are where life safety doesn't really depend on the operation of the backup power source. And you find these, what would qualify here would be gas stations, convenience stores, residential homes, gas stations, farms. And you can understand that why they would allow you to use a portable and not necessarily a permanently installed backup power source, because in most cases they don't have the room for it. They don't have the need to have a permanent backup power source there. So they may have a rollout generator in the back room, in the storage room, that they would roll out and they would connect up when and if they lost power. So the code only goes into takes the steps to tell you how to do this safely, to ensure that if you're going to connect up a backup power source, you do it correctly. And the last one of the four is Article 708, Critical Operations Power Systems, referred to as COPS. Now, these are facilities or portions of facilities that affect national security, the economy, public health and safety, and to ensure business continuity. And these are systems like the 911 call centers, police stations, fire station, air traffic control stations, communications and emergency evacuation centers. And what's interesting here is they don't tell you the time frame that you must have power back up. And really the time frame is dictated either by federal, state, local, or the AHJ has the authority to tell you how quickly you need to have that power switched over to the backup power source in the case of lost power. I think that's everything here. So let's dive in. So now I'm at the point where I'm going to look at the 2026 version of the code, and we're going to talk about all the changes that were made. So the way I structure each one of these slides is I will tell you the article that's been changed, and I try to highlight in yellow what has actually, the wording that has been changed. And in that upper green box you see on here, the industry impact, I try to define what I see as the impact to everybody out there with the change that's being made here. So in this case, it's really just they changed the wording of the bypass definition. So, and in this case, what I did was I showed you that in the 2023 and in the 2026 version of the NEC, no change was made to the definition of a transfer switch. It's an automatic or non-automatic device that transfers one or more load conductors from one power source to another. And really, it doesn't do I don't think it does justice to what a transfer switch really is. So let me try to put it in layman's terms. A transfer switch is there. It's part of the electrical system. It's constantly monitoring the presence of normal power. And when normal power goes down, the transfer switch will send a start signal out to the generator. And once that generator gets up to a proper voltage and frequency, it will switch power from the dead normal source over to the backup power source, up over to the generator. And while it's on that generator, if it's constantly monitoring the presence of the normal source, and when the normal source comes back, it'll switch back to the normal source. It wants to be on normal, but its priority is to get power to the loads as quickly as possible. All right, so further down here, you see the definition that was in the 2023 version of the NEC on bypass isolation transfer switch. And there's quite a few words here. So they condensed it down to just a few words, but the intent is the same. There's really no change to the intent here. And what you see here and off to the right is a picture of a bypass isolation transfer switch. And what is a bypass isolation transfer switch? it's really basically two transfer switches in the same enclosure. And those two transfer switches are connected in parallel so that if the transfer switch goes down, either for servicing or for testing purposes, you have a way to get around that transfer switch. You have a way to get power to your loads, even if your transfer switch fails. All right, so the first change here that we're going to talk about is where they have a temporary source of power for servicing of the alternate source of power. So they changed a couple words here. They said they changed maintenance or repair to servicing, which, okay, maybe they're trying to soften the blow on something that might be down for repair. They added 3 extra paragraphs. There was already something in here with the first 7 paragraphs on how this is properly done. Actually, let me do that. Let me jump to the next slide, which will show you. This is a complete section that we're talking about. And as you see down and below are the 3 sections that they added. They changed the word servicing up above and they added the 3 down below. So what they did was they said that, look, if you're going to connect up a temporary power source, you need to have an overcurrent protection device in there to make sure that that temporary power source is protecting the download equipment, the downstream equipment, as well as the cabling. Common sense. And number 9 just talks about if the permanent generator was solidly grounded, so must that temporary portable generator that you hook up. And you must switch that grounding terminal the same way, or grounding conductors the same way you transferred them with the permanent power source. And they also stated that section 700.10D4B shall not apply. So let me tell you about that section. What's critical to that backup power source is the start signal. And there was some concern years ago, I can't remember the exact date of the change to the NEC, but that said that you will monitor the integrity of that start signal that's going out to that permanent generator. And if that connection to start that generator is severed, it's shorted, or it's cut, it's removed or damaged in some way, you will start the generator or you will enunciate an alarm, or visual or audio. So here they're saying that once you hook up that temporary power source, you might not have the ability to continue to monitor the integrity of that start signal. So let me jump back a slide. And here's that section I talked about. It's down here in the gray, down at the bottom. And this just talks about what does not apply. They're saying that if you hook up that temporary power source, this doesn't apply. And again, what this whole paragraph that's on this next slide is the case where they've identified that if there's a single source of power, and that single source of power, that generator is down for service, you're out of commission. And you certainly don't want your emergency systems not to have a source of power if you're down for a repair. So they want to have the ability to hook up a temporary power source. So now, this is interesting. Article 517 is specifically for healthcare facilities. Now we know as a part of emergency systems, Article 700, healthcare facilities are included under there. But they have this special section in the NEC that goes down into a further detail, defining exactly what their expectations are for a healthcare facility. So here, in this case, they added a section, a whole section here that says that if you have a single on-site power source and it's down, these are the things that you will do. And it says basically the same things that were covered in Article 700, but it tells you that they want to make sure that this temporary power source is as large as your permanent power source, so it can supply the same amount of power. It also goes into details and defines, I think, Section 3 of this actually goes in there and tells you, I want the stairways lit up. I want the hallways lit up. I want elevators to have power. So it defines exactly what their expectations are with a healthcare facility in regards to that temporary power source and what you have to power up. And what's even more interesting to me is in this Article 517, so they talked about the case where there's a single generator powering up your healthcare facility. But now they're addressing the fact when there's multiple generators being paralleled together to power as your source of backup power to that facility. And they're saying that not only if there's a single generator, they're worried about if one of those multiple generators goes down, and they're mandating that you will have the ability to connect up a temporary power source if one of those generators goes down. And then they detail define in greater detail here again what kind of expectations they have for the size of that temporary generator. They talk about how it's connected, making sure that it can operate seamlessly with the permanent generators. Yeah, I think that's it. And the photo off to the right here just shows a method to connect up a portable generator. The connections would be at the bottom of that enclosure, and then the top would be a manual transfer switch that you would use to swap between the permanent generator and the temporary generator. All right. They also made a change, just a small change, to where they talk about microgrid systems. This is where you have microgrids are becoming more and more popular, obviously, with people having solar panels. So this is, let's imagine a casino that has a solar panel array out at their facility. They may also have a fuel cell system. They may have a battery backup system there. They may have a generator too. But they're saying that if you're going to, if all of these systems or one or multiple systems are used as your backup power source, you will include an interconnection equipment listed for emergency use. So what is that saying? That's really pointing you to UL 3008, which defines an emergency interconnection equipment. So it's saying that if you're going to have a microgrid system, you really need to use a UL 3008 piece of equipment as that interconnection means. The same wording that's shown here for emergency systems is also in legally required standby systems. I didn't include that here, but really the wording is just the same. They just added the fact they want you to use UL 3008 piece of equipment. So I want to back up a second and just talk about the NEC and what I've seen over the years. So back in 2014, we found that in the code, it said that if you have a single generator, this is the first time this has appeared in the code. If you have a single generator, you will have a permanent means to connect up a temporary means of power if that one generator is down for servicing. So it was a great idea. So I guess maybe something happened where COP system was not powered up because the generator was out of service. So they said, well, let's make sure that there's an ability to connect up a temporary power source in parallel with that permanent generator. Well, it took 3 years later, that was in 2014, 3 years later, they said, you know what, that was a good idea for COPS. We should also include it for emergency systems. We should say that if there's a, sorry, I'm talking about transfer switches now, not generators. They're saying that if your loads are powered by a single transfer switch, and if that transfer switch is down for servicing or testing, you will have an alternate way to get around that transfer switch. So anyway, it was in COPS in 24, so I'm getting all confused here. Sorry about that. So anyway, I was talking about generators. The generators for emergency systems was added in 2017. Now, if we talk about transfer switches, that was added in 2020 for COPS. Then they said in 2023, hey, that's a good idea. We don't want a single source of failure to cause our emergency systems to be down. We want to add it in for emergency systems. So they added it in there, but they did a couple other things too. They changed the wording some. They said, oh, let's call it redundant transfer equipment. Let's not just call it bypass isolation transfer switches. We're not trying to cater to a specific type of device. Maybe there's another way to get around the transfer switch. So they called it redundant transfer equipment. And they also said that, look, they don't want to put a burden on people. Emergency systems could be, again, it could be a casino or a hotel or something. And maybe if that facility is vacant for a certain period of time, you can service your transfer switch and you can get it back up and operational. And you really don't need a way around that transfer switch. So they said, let's put some exceptions in there saying that if you have these certain situations, you don't have to have a backup or a bypass isolation transfer switch. And then the next step was in 2026, which we're going to talk about now, and I'll go down into further detail later. But they said, okay, hey, maybe we should put this in legally required standby systems too. And they decided that they didn't want to say mandated for legally required. They wanted to say it's permitted for use. So we'll talk a little bit about that later. But the other thing that they decided in 2026 was, this idea of redundant transfer equipment. We never defined it. People were confused by what it actually meant. So let's just exclude that wording altogether and go back to using bypass isolation transfer switches. So you can see that the codes and evolves over time, and it may take 2 steps forward and then 1 step back to make corrections as time goes on. And what's interesting here with bypass isolation transfer switches, I can tell you that in the last 40 years, not a single hospital was built without using a bypass isolation transfer switch so that they can get around the transfer switch, just to facilitate testing of that transfer switch, which they have to do every month. And they have to test the generator every month. And they don't want to do it while power is feeding to their loads through that transfer switch. So they want to bypass the transfer switch, make sure the power's going to the loads while they test that equipment or do their servicing or repair or lubrication or whatever they want to do. So here's a case where the code is just catching up to what the industry has already been doing for many, many years. Because no professional engineer or facility owner wants to be on the news or being hauled into court trying to explain why they didn't provide a path around the transfer switch in case it was down for servicing. So let's talk about the specific change that was made. So this is emergency systems. Maybe instead of talking to this slide, I will jump to the next slide, which shows you what the wording was in 2023 and what the wording is today. So you can see that there was a section that said bypass isolation transfer switches are permitted for use anywhere. And then they talked about that new paragraph I said they added in 2023 that talked about redundant transfer equipment. And then there's the exceptions that are listed here, saying that these facilities do not require that redundant transfer equipment. So they changed that wording. They got rid of the exceptions, but they said for occupancies listed in paragraph 700.10 D1, they're not required. So we'll get to that after we touch on some of these other things here. So number one, you see that they changed the wording a little bit to say that the bypass transfer equipment shall be provided while maintaining continuity of power. So what that really means is that there are manufacturers out there who are selling bypass isolation transfer switches that power will drop out of the loads as you switch from the transfer switch to the bypass transfer switch. And this is saying that they don't want that. They really want continuity of power. If you're gonna parallel the two transfer switches together and you're gonna go from one to the other, let's make sure that you don't cut out power to the loads, which is a good idea. And then section 2 is just different wording, but it really means the same thing. What they really want to do is be able to isolate and pull out that transfer switch and maintain it and service it if needed. So it's just saying it will be disconnected from everything. So do I have it on the next slide? Let's see. Yeah, so here's the section that they referenced in saying that in these cases, you don't have to have a bypass isolation transfer switch. And what's funny is that this section here is in the area of the code that talks about fire rating. And it talks about, in these situations, you must have a 2-hour fire rating or you must have sprinklers. So it really has nothing to do with protecting or safeguarding people inside the facility. So if you read over what it says here, and these are the cases, keep in mind, these are the cases where they say you do not need to use a bypass isolation transfer switch. So if there's less than 1,000 people, so if there's 998 people in the facility, you don't have to have a bypass isolation transfer switch. That doesn't make much sense. The second one saying that in here, they're talking specifically about the ability of a fire truck to get access to an area to fight a fire. And they're saying, okay, if the building is under a certain height, you don't have to have a bypass isolation transfer switch. And then they define educational occupancies of more than 300 people. So if I have an educational facility that only has 250 people in it, you're saying I don't need a bypass isolation transfer switch. Really kind of ridiculous. I really think they put people at risk here with this specific change. So not only do I think that, but so did UL and NEMA. So there's this thing called a tentative interim amendment. And this is when you think there's a change been made to the code and the code has been issued, and you think that that change is important enough. It's important enough not to have to wait to the next issuing of the code. You are looking for an interim amendment to the code. This is how you do it. You submitted a TIA. So UL and NEMA got together and they wrote up this TIA, and I think I have the exact wording, at least as it was a few months ago, on what they intended to submit to the NFPA to get this wording changed, saying that they disagree with this exceptions that they now put in there. They think it puts people at risk, and they want an amendment issued. So NFPA will take this TIA and they'll review it, and they'll decide if they will or will not issue a tentative interim amendment to the code. COPS also changed that wording. They changed the wording the same way that they did in the emergency section. The only thing that's different here is they don't have any exceptions. This just shows you the way it was in 2023 and the way it is now. They never had any exceptions. If it's a COPS, you will have a bypass isolation transfer switch available. All right. So this is where they thought, hey, look, now we have a requirement for a bypass isolation transfer switch in COPS. We have it in emergency systems. Maybe we should have it in legally required standby systems. So this is kind of funny. What they actually did here is they said, okay, we don't want to mandate it, but we want to make sure that if it's done properly. So they tell you how to do it properly. But instead of saying you shall have, they say you're permitted to have a bypass isolation transfer switch in these cases, and this is how you hook it up. So I think the next slide, let me just jump to the next slide. Yeah. So this shows you what was in there before, no reference to the needs for a bypass isolation. They're just giving you permission that you could use one. And now they say they changed the wording to say that you are permitted if you have if your legally required standby loads are supplied by a single feeder that go through a transfer switch. So it's kind of funny, but I think that now if you read this in the literal sense, what they took out is the ability to use a bypass isolation switch anywhere, except for if your required standby loads are supplied by a single feeder. That's not what they meant. They made a mistake. They reworded it the wrong way. And I think someone said that somebody was thinking about submitting a TIA also to change this back to make it clear. It's not what they meant, but to make it clear that you can use a bypass isolation switch anywhere you want in the system, not just in this specific case. So again, 2 steps forward, and sometimes it's 1 step back. So what was added, another thing that was added in the definition section is they finally defined a power control system, a PCS. It talked about PCSs within the code in the past. It's part of an energy management system, or it's a type of energy management system. But now they've actually pulled it out and give it a little bit more prominent view, and they put it in the definition section saying that a PCS, and as described here, I'm not going to read it to you. They did differentiate a PCS multi-source system and a single source system. And then with a single source, you're obviously just managing the loads. With a multi-source, which means multiple generators, a PCS will have to parallel those generators, and it can be arranged so that that PCS is looking at the load, looking at the amount of power that your power sources are providing, and turn those power sources on and off as needed by the load demand. And also, Article 705.13 was renamed from Energy Management Systems to Power Control Systems. So I put this in here. This is the section that they changed, and they renamed it as a power control system. And I think they went down into a little bit of extra depth in a couple of these areas, but this section, I just did the headings of the section. I didn't do all the wording in there because it would have filled up 3 pages. So there's a couple things in here that define exactly how a PCS system will work, how it monitors and controls, and how it responds to a malfunction, and how it's marked. So it would be worth reading if you're going to have a PCS type system in a facility. So here's an automatic load connection. The picture in the bottom right here shows a load management system that ASCO sells. And this just sheds load as needed. And really the purpose here, and the reason for the wording changes here, traditionally a energy management system will just shed load. That's all it does, is it shed loads. But a power control system is managing the sources as well as the loads. Or it could be just managing the sources and leaving the loads alone, or vice versa, just managing the loads. So it says that if the connection of the load is automatic, an optional standby system shall comply with these sections down below. It says it's either the standby source will be capable of supplying the full load, but if it's not able to supply the full load, you must use an energy management system. And the system will be either working according to what's defined here in number 1, or using a PCS number 2. So let me just look at what these 2 sections actually say on the next slide. So it says it'll either work this way or this way. So load management, again, it just talks about shedding of loads for a traditional energy management system. And with the PCS, it just talks about what I already mentioned. It just talks about the ability for the PCS system to monitor and change the sources as well as the loads. So I think they're just going into further detail about what a PCS does, how it works, and what it's capable of doing. All right, so now we get to a point where we're still in the energy systems section of the code, but it's not about power transfer and backup power anymore. It's about some of the other requirements that have changed. So there were 2 more paragraphs that were added to this specific section here. And yeah, let me just talk to this. So prior to this, paragraph 5 just said that if you have cable or raceway encased in concrete, you must have a minimum of 2 inches of protection around that conduit. So now they clearly define that that's measured from each point on the surface of the cable or raceway, and it must provide a 2-hour fire rating. And that's not just your judgment. You need to have that documented by a licensed professional engineer and available for the AHJ if you request it. Or your other option, if you just want to bury it in concrete, you have to go to now up to 5 inches of concrete measured from each point around the surface of the cable or raceway. And you look at the photograph off to the right, which I think is pretty entertaining. I mean, look at the size of the concrete or the thickness of the concrete. Obviously, they're shooting for the 5-inch thickness to get you that 2-hour fire rating. And then they're preparing they formed up the upper section here just to pour concrete to protect the upper sections of that conduit. So anyway, just a change to the thickness and the requirements to get that 2-hour fire rating. Yeah, so this is how that whole section looks with the change to paragraph 5 and the addition of paragraph 6. You know, there's other ways to protect it to get you your 2-hour fire rating. It's, you know, if you have an automatic fire protection system. Okay. Next one up was arc flash marking. So this is pretty interesting because in the past, the only time you were required to identify and mark it as an arc flash hazard is when you're over 1,000 amps. So now, for all non-dwelling unit services and feeder equipment, you must have an arc flash marking label. And here's an example of the label off to the right here. You see you must identify the voltage, the arc flash boundary, the incident energy, and the when that assessment was completed. So again, a bigger push for warnings to safeguard people in and around service equipment. Surge protection. So they're going to change to the surge protection devices, saying that now in areas that are similar to a bedroom, and this is to come in alignment with the building, what the building code already says, what our building code already states. So they're saying that areas designed for exclusive use as sleeping quarters in things like police stations, fire stations, ambulance stations, rescue centers, anything that's used exclusively as a bedroom facility will have a surge protected device. I thought that was pretty interesting. Change to service disconnects. So now for 1 and 2 family dwellings, they're saying that any service disconnect must be installed in an outdoor location. I guess previously they could be installed indoors. And they're saying it's outdoors, it's either on the dwelling itself or within sight of the dwelling unit. And if it's something other than a 1 and 2 family dwelling, you can actually put it inside at the nearest point of entrance to the service conductors into the facility. So I thought that was pretty interesting. So now that we know where that service disconnect is located and the new requirements surrounding that, they've revamped some sections here saying that they want that service disconnect permanently marked. So, and as you see in the right-hand side of the slide here in the upper portion, it's, you know, they're clearly identifying the service disconnect with a label that says service disconnect. And they want emergency disconnect on the outside of the enclosure. So this is typically a type 3R rainproof enclosure cover. They want it done with a red background, white text. So they go into great details to make it easier for firefighters or anybody going into the facility to clearly understand where the service disconnect is. Pretty interesting. EVs, electric vehicle supply equipment. Some few changes here. I guess we've had problems with safeguarding these types of facilities. So they're not talking about somebody who has a single family home with an electric vehicle or even a multi-family dwelling. with electric vehicles. They're talking about a facility that has a large number of electrical vehicles possibly plugged in at any given time. And they want to make sure that there's an emergency disconnect. And they're saying, they're giving some guidelines on what that emergency disconnect says, how it's marked, where it's located, no closer than 20 feet from the equipment, and no more than 100 feet from it within line of sight. So they go into a little bit of details here about that emergency shutoff for situations like this. And the last thing I have to touch on here is just another thing with our electric vehicle power transfer systems. This is in that section, power transfer, the equipment connection. There's a few revisions stating exactly what they're looking for. The three things that I'm pointing out here that were specifically mentioned is they're saying that they want to make sure that you use a listed receptacle for both uses. They want to make sure that you're using a 50 amp rated receptacle, shall not be installed on a 40 amp branch circuit. Okay, logical. And they are approving the lock and pin sleeve type device in certain applications. Let me go to the next slide, which actually shows you the complete section. Excuse me. So this shows what it stated in 2023 and how they elaborated in 2026, just to provide some additional guidelines as well as requirements. So just to rehash the learning objectives. So we talked a little bit about the code making process, how you have the opportunity to go in and make some suggested changes to the code. We went over the 4 electrical systems that deal with backup power and power transfer. The 708, this emergency system. 701 is legally required. 702 is the optional standby systems. And 708 is COPS, critical operations power systems. And yeah, there's a lot of changes in the 2026 NEC. There's thousands of them. We only touched on a few here. So if you want to get in there and start looking for things that might affect your business and what you're working with, I think you should do that. More extensive changes are coming in 2029. So if you want to get in there and jump in and have the opportunity to make some suggestions, go ahead and do that. I think that's it. So hopefully this was worth a while. All right, Lori, is there any questions or comments? This is your opportunity to stump the presenter. So if you have any questions, feel free to put them in the chat and I will do my best to answer them. And if I don't feel comfortable, I'll let you know, because I certainly don't know everything.
Thank you so much. Thanks, Robert. Really appreciate that and all that great information and all those changes that you highlighted. Just as a reminder, if you have a question for Robert, you can just navigate to the Q&A on the screen at the Q&A module and type in your question. We do have a couple of questions. How do I gain access to the NEC 2026?
Yeah, there's a couple things you can do to get access. I mean, one is you buy the newest version of the code. That's like $220, I think, for that code book. It's over 900 pages, so if you break it down per price per page, it's probably a pretty good deal. The other way is, which I use, is through the NEC link or NFPA link, which gives me access online to any of the NFPA codes that I want to review and look into and search. It's really, really a nice tool, but it's a little bit pricey. I think it's like $130 a year if you're looking to have that recurring renewed. If you're only looking for a 1 year, I think it's like $170. There's bigger discounts for the more people in your company that you might get signed up. I'm not sure what those discounts are.
Great. Thank you so much, Robert. Next question, will there be any prescriptive changes for a single generator with multiple transfer switches? Sorry, a little tongue-tied there. Will there be any prescriptive changes that come for a single generator with multiple transfer switches?
I don't see anything coming down. You know, right now we talked about it in the presentation deck that if there's a single generator, obviously they want to make sure that you have the ability to connect up a temporary power source in case that single generator is down. But I'm not aware of any changes that are coming. I mean, there could be something, but I'm not aware of it.
Okay, great, thank you. Next question. If a TIA is issued for an NFPA code, where can I see it?
Yeah, it's a good question. The only way you're going to see a TIA, they don't put them in the code books if you bought the code book, but if you had NFPA links, or even if you go, you don't have to buy anything. You can go right to the NFPA website and you can look at a code and it'll provide you with information on the code itself. You can view the code, I think. They give you still access to that, but they'll also list all the TIAs that are in force. And actually right now, if you went into the NFPA website and you looked at the 2026 NEC, there are already some TIAs that are in there making changes, interim changes to specific sections of the code.
Okay,
so
great.
the NFPA website.
Thank you. And then what other changes would you like to see in the next NEC?
Yeah, another good question. I guess there's a couple things that I mentioned as I went through that deck that I didn't like that were made. One was in the legally required standby systems, excuse me. So in the legally required, man, can't talk now. But anyway, for the legally required standby systems, they took the bypass and specifically stating that bypass isolation transfer switches can be used, are permitted for use anywhere. And they took that out, and now they only reference it in use if there's a single transfer switch feeding your emergency loads, which isn't right. And I know they're going to change it. So I'd really like to see that happen. The other thing that happened a number of years back was, you know, we talked about the importance of those engine start signals that go out to the engine generator from the transfer switch that is telling the generator, look, it's time for you to turn on. And the importance of monitoring the integrity of those cables if they're shorted or broken. When that code change came out of monitoring the integrity of those wires, it said that not only are you going to start the generator, but you must also have an audible and visual alarm to tell you why that generator has been started. And since then, the code changed. And they don't tell you they don't mandate the need for a audible or a visual alarm. They just say you start the generator. So you could go to your facility one day and see the generator running and not know why. I think that's a mistake. I think that's the only two that come to mind.
Okay, great. Thank you so much. It looks like that might have been our last question. So before we wrap up, Robert, thank you again for all the great information, all the details, and the update on the changes. And as you noted, this is just touching on them. There's a lot more out there. So appreciate that. Do you have any final thoughts for our audience before we conclude the event?
Yeah, I just want to thank you, everybody, for sticking with me. And as I went through this, obviously I stumbled a couple times. This is a lot to remember, a lot to go over, but I hope it was worth your time. And I hope you find it a benefit. And please feel free to get in that code and look for the changes and make sure that if you can implement them now, please do. I think it's well in your best interest.
Great. Thank you so much.
Thank you.
And yes, a lot of great detail. Good thing that it's recorded. People can go back and refer back to it. So